Wi-Fi is a truly amazing technology. It lets us connect to the internet without wires. Information flies through the air. It reaches your phone, your laptop, your tablet. This connection is invisible, yet it is incredibly powerful. We use it constantly, often without a second thought. It has become a fundamental part of our modern lives, like electricity or running water. We expect it to be there, always ready to link us to the vast digital universe. Imagine a world without Wi-Fi. It is hard to do so now. We use it for so many things. We stream our favorite shows and films. We chat with friends and family across the globe. We work from home or coffee shops. Students use it for research and learning. Businesses rely on it for daily operations. Wi-Fi keeps us informed, entertained, and connected. It is a silent force working tirelessly in the background of our busy lives. The term Wi-Fi itself is quite interesting. It stands for wireless fidelity. It was designed to be a user-friendly name. Now, the word Wi-Fi is known everywhere. Truly, Wi-Fi is a cornerstone of modern digital life. To understand Wi-Fi, we need to meet the key players. The first main player is your wireless router. This little box is the heart of your home network. It broadcasts and receives the internet signal. Without a router, your devices would have no way to talk to the internet wirelessly. Then we have your Wi-Fi enabled devices. These are your smartphones, laptops and tablets. Smart TVs and game consoles also join this team. Even some kitchen appliances now use Wi-Fi. Each of these gadgets has a tiny built-in wireless adapter. This adapter is like a small antenna and radio. It allows the device to send and receive data using radio waves. Think of the router as an airport control tower. Your devices are like aeroplanes. The router manages all the incoming and outgoing data traffic. It makes sure that information from the internet reaches the correct device. It also ensures that requests from your devices go out to the internet. This coordination is vital. It keeps your connection stable and organized. The router works hard to keep everything running smoothly. It is a testament to clever engineering and scientific principles working in harmony. Let's delve a little deeper into the router's role. This device is much more than a simple signal broadcaster. A modern router performs several crucial tasks simultaneously. Firstly, it connects to your internet service provider, usually via a modem. The modem translates the signal from your ISP into a format the router can use. Once the router has an internet connection, its next job is to create a local network. This is your own private Wi-Fi network within your home or office. The router assigns a unique local IP address to each connected device. Think of an IP address like a specific house number on a street. This ensures that data packets are delivered to the correct destination. The router also acts as a basic firewall. A firewall is a security system. It helps protect your network from unwanted intrusions. It monitors incoming and outgoing traffic. It can block suspicious data packets. This provides a first line of defense against hackers and malicious software. The router is truly the unsung hero of your home's connectivity. How does your information actually travel through the air? It starts with digital data. All the information on your computer or phone exists as binary code. This code is made up of just two digits, 0 and 1. These are called bits. Every letter you type, every image you see, every sound you hear is represented by a unique sequence of these zeros and ones. Your Wi-Fi device needs to send this binary data to the router, or the router needs to send it to your device. To do this, the binary code must be converted into a form that can travel wirelessly. This is where the wireless adapter inside your device and router comes into play. It takes the stream of zeros and ones. It then translates them into radio waves. The process of converting digital data into radio waves is called modulation. The zeros and ones are used to change certain properties of the radio wave. When these radio waves reach the receiving device, the process happens in reverse. This rapid conversion and reconversion happens constantly during Wi-Fi communication. Radio waves are a type of electromagnetic radiation. They're just like light, X-rays, or microwaves. These waves are part of the electromagnetic spectrum. The special thing about radio waves is their wavelength. They have longer wavelengths than visible light. This means they can travel long distances and pass through objects like walls. This makes them perfect for wireless communication. Think of radio waves like ripples in a pond. When you drop a stone into water, ripples spread outwards. Radio waves spread out from the router's antenna in a similar way. Your Wi-Fi-enabled device has its own antenna. This antenna is designed to catch these specific radio waves. When your device wants to send data back, its antenna creates its own radio waves. The radio wave itself isn't the data. It's the carrier for the data. It transports your digital information from one point to another without any physical connection. This ability to carry information is what makes radio waves so useful. Wi-Fi operates on specific frequency bands. The two most common bands are 2.4 GHz and 5 GHz. A hertz is a measure of frequency, meaning cycles per second. Gigahertz means billions of cycles per second. These are very high-frequency radio waves. Think of these frequency bands like different motorways. Each motorway is reserved for certain types of traffic. The 2.4 GHz and 5 GHz bands are reserved for Wi-Fi and some other short-range devices. The 2.4 GHz band was the original Wi-Fi frequency. It is good at traveling through walls and other obstacles. It also has a longer range than the 5 GHz band. However, it can get quite crowded. Many household devices use the 2.4 GHz band. This crowding can lead to interference. The 5 GHz band offers a solution to this crowding. It provides much more bandwidth and is less prone to interference from other household appliances. This generally means faster speeds and a more stable connection. However, 5 GHz waves do not penetrate solid objects as well as 2.4 GHz waves. Many modern routers are dual band. This means they can broadcast on both 2.4 GHz and 5 GHz frequencies simultaneously. Within each frequency band, there are smaller divisions called channels. Routers can often automatically select the best channel to use. Having an open Wi-Fi network is like leaving your front door unlocked. Anyone nearby could potentially access your internet connection. This might not seem like a big deal at first. However, the risks are much greater than just slower internet speeds. An unsecured network can expose your personal information. It can make you vulnerable to cyber attacks. Protecting your Wi-Fi network is incredibly important in today's connected world. If someone gains access to your Wi-Fi network, they could potentially see the data you send and receive. This could include passwords, bank details, or private messages. Malicious actors could also use your internet connection to perform illegal activities. Furthermore, an unauthorized user on your network could infect your devices with malware. Securing your Wi-Fi helps create a barrier against these kinds of threats. Wi-Fi security is not just an option, it is a necessity. To protect your Wi-Fi network, we use security protocols. These are like special codes or passwords for your Wi-Fi. They encrypt the data that travels between your devices and the router. Encryption scrambles the data. This means that even if someone intercepts the radio waves, they cannot understand the information. Only devices that know the correct password can decrypt the data and make sense of it. Over the years, Wi-Fi security protocols have evolved. One of the earliest was WEP, which stands for Wired Equivalent Privacy. However, WEP was found to have significant security flaws. It is now considered outdated and insecure. Next came WPA, which means Wi-Fi Protected Access. WPA was an improvement over WEP. Then came WPA2, which became the standard for many years. WPA2 is much more secure than WEP and the original WPA. The latest and most secure protocol is WPA3. It offers even stronger protection than WPA2. When setting up your Wi-Fi, always choose the most secure protocol that your router and devices support. And always use a strong, complex password that is difficult to guess. The impact of Wi-Fi on modern communication and connectivity is truly profound. It has fundamentally changed how we live, work, and interact. Before Wi-Fi, internet access was tethered to a physical cable. This limited mobility and flexibility. Wi-Fi cut those cords. It unleashed the internet from desks and walls. It allowed us to connect from almost anywhere within range of a router. This freedom has sparked innovation and transformed entire industries. Consider how Wi-Fi has revolutionized education. Students can access vast libraries of information online. They can collaborate on projects from different locations. In the world of business, Wi-Fi enables remote working and flexible office spaces. It supports instant communication and data sharing. Wi-Fi has also played a crucial role in the development of the Internet of Things, or IoT. The invisible web of Wi-Fi is connecting not just people, but also the objects around us. Please subscribe to our channel for more informative videos on technology and Wi-Fi.